So what we have here is the list of the vocabulary and the correct definitions. You need to make sure that you have this list written down or at least checked. I am going to be posting this exact list on Google Classroom shortly, so you can get it there instead of taking a picture. Make sure you do know these definitions for the test tomorrow. Okay, you should. Now, in this particular scenario, we had the marble at the top of the ramp. The marble, according to the information given to you, is at the top of the ramp and it is not moving. So the only energy present here would be gravitational energy. Okay. The final scenario, or the final position of the marble is somewhere halfway down the ramp, so it's like somewhere around here, and you are told that it's moving. And as a result of it moving, it has some kinetic energy and it has some gravitational energy in this case here. And so as a result of that, the energy equation that you would write is E gravitational is equal to E kinetic plus E gravitational. Is work involved in this scenario? The answer is no. I know that work is not involved because there is no energy transferred into or out of the system. Questions about that? In the second scenario, on station number 3, we have the scenario where the shoe is sitting on top of the compressed spring. At this particular instance, the spring is compressed, the shoe is not moving, and the shoe is at its lowest height. So you would say that this one has just all spring energy at this point, because the spring and the shoe are the system. In the final scenario, the spring is completely relaxed, the shoe is moving, and the shoe has changed height. So that would tell me that you would have some kinetic energy and some gravitational energy, and the amounts have to equal each other on the right side as they do on the left side. So in this case, we would have spring energy equals kinetic energy plus gravitational energy. Is work involved here? No, because the energy, there is no change in energy in the system. Okay, so that would be station number 3. At station number 4, the system is similar, or the scenario is similar, but the system is different. In this case, the ball is the system only. Initially, the spring is compressed, the ball is not moving, and the ball has zero change in height. So as a result of that, there is actually no energy at the beginning or the first initial situation for the energy bar chart. The final scenario, the spring is relaxed, the ball is moving, and the ball has changed height. So in this case, we would definitely have some gravitational and some kinetic energy. And where did the ball get its energy from? The ball got its energy from the spring. So when I write this particular energy equation, I'm going to have 0 initial energy plus work equals kinetic energy plus gravitational energy. And your bar chart needs to look just like this. Okay? So is there work involved? The answer is yes, because the spring is giving energy to the ball. Questions about that? In the fifth system, we have a car, and it is at a loop in the top of the loop-to-loop. Initially, the spring is compressed, the car is not moving, and the car has not changed height. So there's actually no energy at the beginning, because in this case, the car is the system. So then what ends up happening is that if the spring relaxes, the car is now moving, and the car does have a change of height, and it does happen to be at the top of the loop. So in that case, as we've discussed earlier, we would have half kinetic and half gravitational. So in this case, initial energy is 0 plus work would equal kinetic energy plus gravitational energy. And that work came in the form of the spring. So in this case, the spring gave energy to the car. Okay? And then the last scenario, this one many people screwed up throughout the course of the day, so I want to take a couple seconds to discuss this. Initially, the car is moving, and finally, the car has come to a stop. But the car is the system, not the car on the table. So the car is moving initially, so it has all of the kinetic energy. Finally, it is stopped, it doesn't have any energy. And since the car is the system, it had to transfer energy out in the form of work. So in this case, you could write friction. So my energy equation here would be EK minus work equals 0. So is work involved? Yes. The car is transferring energy to the table in the form of friction. And so that sums up the review stations that we did in class today. Hopefully this will be helpful for you in terms of studying for the test tonight, and the test is tomorrow.